Alright, I'm back with another example, this time with a bunch of minus signs, which I know a lot of you don't like, but we're going to be able to handle this. Same steps as always. We just factor the top and the bottom, and then we'll be able to cross some things out. Alright, the top this time is just a binomial. Those are typically much easier to factor. I can pull a 2x out of this. 2 goes into 2, 2 goes into 12, there's an x in each of them. Okay, when I divide 2x out of 2x squared, I'm just left with an x. Dividing 2x out of this 12x, I got an x minus 6. Okay, let's see what happens when we factor the bottom. This is a trinomial, so it takes a little bit more work. This is where I write down my two numbers. Okay, they add to the middle, and they multiply to the end. Okay, so two numbers that add to negative 2, multiply to negative 24. Okay, when it multiplies to a negative number, that means one of your factors is going to be positive, one is going to be negative. Okay, they add to negative 2, so that means that the negative number has a higher value than the positive number, and they're different by 2. That's kind of like a clue. Another thing you can do is just trial and error. What are the factors of 24? 24 and 1, there's no way you're going to get 2 from subtracting them. 12 and 2, same deal. 8 and 3, subtracting them doesn't give you 2. 6 and 4, I think we're onto something here. If we do negative 6 and positive 4, I think you'll agree they multiply to negative 24 and they add to negative 2. Okay, so this tells us how to factor a trinomial. You just put an x in front of these numbers. So it's going to be x subtract 6 and then x plus 4. Okay, and now the best part. Top and bottom have an x minus 6. Those go away. All we're left with is the 2x and the x plus 4. And that is done. Alright, I'm back with our last example. I promised we'd see something with a difference of squares. Maybe you shudder when you hear that. Gave you a hard time in grade 10. Difference of squares is a difference, which means subtraction, of two terms that are perfect squares. Okay? So x squared is x squared, which means the square root of it is x. 9 is 3 squared. Okay? A difference of squares, I'm just going to write out what to do here. If you have two squares, I'm going to call them a squared and b squared. Factoring them is really nice. It's a minus b times a plus b. So you just change the sign between them. I think you guys would prefer numbers here. So if I have x squared minus 16, well, the square root of x squared is just x, and the square root of 16 is 4. So to factor that difference of squares, it's just the two square roots, subtracting one time, adding another time. I'll just throw another real quick example at you. Our example, x squared minus 9. That's x minus 3 times x plus 3. Okay? And I'll try to prove it to you. If we expand these brackets, I'm going to get x squared plus 3x minus 3x minus 9. These two middle terms are going to add up to 0, and we just are left with x squared minus 9. So that's why it works. That's why difference of squares is valid, and it saves you some time. All right, so we already know the numerator here factored is x minus 3 times x plus 3. Okay, and that order doesn't matter. You can do x plus 3 times x minus 3. That's absolutely fine. We have a trinomial. Okay, so I didn't make this one easy on us. We need to find two numbers that add to 4 and multiply to 3. That actually shouldn't be too bad. I think that's going to be 3 and 1. Okay? So when we factor our denominator, it's going to be x plus 3 times x plus 1. All right. That's very satisfying there, crossing off those x plus 3's. And our answer is just what we have left, x minus 3 over x plus 1.